Our webinar today will cover how Turner Construction Company uses Assemble to visualize and communicate cost. Now let's get started. It's my pleasure to introduce to you Don Henrich, President and CEO of Assemble Systems. Go ahead, Don.
Thank you, Ariel. Okay, let's proceed. I'm the CEO of Assemble, and I've been working on BIM and VDC for 15 years. When I started, we worked on a special project for construction that resulted in software we called 5D. It was for estimating, which is what we will focus on today. I'd like to introduce our guest and customer, Jeffrey Pinheiro. I recently met Jeff at the Building Content Summit in Toronto, where we were both speakers. When I watched Jeff's approach to the use of models and how to help others do more work with more data, I asked him if he would share some of his expertise with us here today. Jeff's a licensed architect with 13 years in the industry and 3 years at Turner. Currently, he manages VDC for Turner's New England region and is active in the BIM community with his blog and appearances across the country, known as the Revit Kid. Today's rapid fire agenda will include short intro, notice of a new Assemble color by property workflow that will help you leverage models even more for estimating, scheduling, RFIs, field work, etc. Then Jeff will share some use cases for models in the world of estimating in 5D at Turner. Next, let me tell you what Assemble is. Assemble is a cloud-based system that requires no software, no hardware, and no Revit experience to unlock the data in the building information model. This allows you to minimize risk, understand scope, and improve production. Next, let me show you the systems that Assemble connects. This slide shows many areas, roles in construction, partners, and systems that Assemble can help with. Please contact us to learn how we can help you to connect your construction model to more of these existing systems. This slide, I will let Jeffrey explain this shortly, but suffice it to say that model geometry and data properly organized and conditioned can be a huge time-saving workflow for estimating. Today we'll show for the first time a new capability in Assemble called color by property. I'll let Jeff share more about this, and we can take questions after. This color by property will be on all your Assemble projects soon, in approximately 30 days. And now I'd like to turn the discussion over to our expert in these matters, Jeff Pinheiro of Turner.
Thanks, Don, and thanks for having me. I don't really want to go too much through who Turner is. It's a big machine. I'm only a little part of it, but Turner is one of the biggest construction managers in the United States. You can see just some of our stats: 5,200 employees and 1,500 projects per year. I like showing this image because it's a cool example of, even in our small state of Connecticut, how many neat projects we've done over the last 15 to 20 years. It's an image that we call Turner City, and so this is Turner City for the state of Connecticut. And so at Turner VDC, which VDC, for those of you unfamiliar, stands for Virtual Design and Construction, and we sort of handle the intersection of technology and the construction industry, or in fact the whole AECO industry, including operations. And this is just a little slide showing some of the things that we do on a daily basis and handle from project to project. Anything from 3D printing to 4D, which is model-based scheduling, to coordination, which a lot of people are probably familiar with, and then of course as-built models using things like laser scanning and photogrammetry and so on. But of course for today we're going to focus on 5D, which some of you might know better as quantity takeoff or model-based estimating. And so this is a slide that I like to show in the beginning of a lot of my presentations when explaining what we do at Turner in virtual design and construction. And basically this is a diagram that demonstrates the current process. So this is a process using BIM, using building information modeling, and I think it breaks it down nicely to sort of show that even though this is the accepted process, there's still a little bit of a disconnect. We go from 2D sketches created by the design team, whether it's the architect or the engineers. The design team then goes and creates a 3D model, and then from that 3D model they take the time, and for those of you who are designers, you understand how much time it takes to develop 2D documents from that 3D model. And then ourselves, Turner Construction, and our subcontractors take those 2D documents and now we have to build a 3D building from it. And so the reason I like to explain that is, first, when you think about it, it's kind of a silly process when you break it down in this sort of diagram. But then also, as far as what we do in VDC, I like to say that we're connecting the two 3D elements in this diagram. We're connecting that 3D model to that 3D building. And Assemble is a perfect example of how we're doing that. On the estimating side, as well as just visualizing and understanding the building. Obviously, the other examples I showed before are also another way. But really, it's a matter of sort of connecting that information and that design intent from that initial 3D model to what we're actually building in the field as a 3D building. So for those of you who are not estimators and don't deal with doing quantity takeoff on a daily basis, there's other programs similar to it, but this is a screen capture of on-screen takeoff, which is sort of the standard here at Turner, especially here in Turner, Connecticut, for two-dimensional takeoff. If you're familiar with other programs like Bluebeam or anything like that, essentially you're taking those 2D documents, again, if you think about the diagram, the 2D documents that are created from the 3D model, and you're using basically polygons to pull quantity. So if it's a scaled 2D document, you're able to draw these polygons, and it's going to give you things like perimeter and areas and counts and so on. And I also want you to notice on the left-hand side how there's a bunch of different color schemes and conditions set up. This is going to be important because I want to sort of connect the two when we go into Assemble, but it becomes a pretty important part for quantity takeoff. So then what about 3D models? So what is model-based takeoff like before we use Assemble? And you can see here, this is one of our VDC staff members. He's looking super happy, chilling in his model. And what he's doing is he's actually pulling off quantity. So he's using Autodesk Navisworks, typically is what we use before Assemble, to set up our own conditions and extract data. And then what he's doing is he's exporting that to Excel and then handing that Excel sheet over to the estimator. And that works, and it is technically 5D. We are pulling information from the model and handing it over and using it for quantity takeoff. But the big issue is the barrier created by just handing off an Excel sheet. And to me, that was the biggest issue with this process. And this is a process that's pretty common across the industry, is to have someone familiar with a big bloated program like Navisworks do the work and do the pull off or the takeoff, and then hand it over to an estimator who's more familiar with the actual unit prices and looking through the 2D documents and verifying the data. But again, the big issue here is that now the estimator does not have any relationship with that model. They might have connection with the data, which is simply an Excel sheet, but they don't have the relationship with the model. So in after assembly, you can see the VDC staff is happier. Basically, as a VDC staff member, I would receive models from design teams and vet them out, sort of look at them, see some of the caveats of each model, maybe some of the standards that design team is using, and then basically upload them to Assemble. And once they're uploaded to Assemble, as Don mentioned before, without installing a big bloated program like Navisworks or having to learn a big bloated program like Navisworks or other QTO software, the estimator has a direct relationship now with not only the data, but also the model, and they can make that connection. And so part of what we've done is working with design teams early to let them know that we're going to be doing a quantity takeoff using the model. And I know there's probably a few designers and architects and engineers out there. So these are just some of the rules that, not really the rules, but best practices that we've come up with just by seeing models. And the first thing that a designer will usually say is, how are you going to use my model? And so this is kind of an abridged version of a longer document that we've created, sort of giving some best practices of how their data can be best extracted downstream. And the key here is that we don't want to go in and change anyone's standards. We're not going to tell them that they have to name walls, doors, and windows this way, or categorize things a specific way. But these are best practices that will definitely help you make sure your information is read properly. So obviously, setting the proper wall function, it seems like a straightforward thing, but you'd be surprised how many models have walls that are all set to exterior, or maybe they're all set to interior when they're supposed to be exterior. And that's something where it's easily built into the type of your family and doesn't affect any of your standards, but making sure that if it's a foundation, it's set as a foundation. If it's an exterior, it's set as exterior, and if it's interior, it's set as interior. Again, pretty straightforward, but it makes downstream use of your model much more accurate. Top of wall constraints. Those of you who are building Revit models, you probably know the headache that is top of wall constraints, because it's not always the easiest thing to do. but basically making sure that if your walls are supposed to go to the underside of ceilings, you make sure they stop at the ceilings. If they're supposed to go up to the deck, you make sure they go up to the deck. And that's pretty obvious why that's important as far as takeoff is concerned, because obviously we can miss or add quite a bit of information. And then if you can schedule it, we can schedule it. I'll give a quick example of what this means, but it's a really good mantra to use when you're building Revit models, especially ones that you want to be information-centric. The thought that if you're a Revit user, you know exactly what I mean, that if you have the ability to create a schedule and pull a piece of information off of it, then that means anyone downstream can do the same. So if you can't schedule your windows and schedule the type of window, then that means no one else can. So it's sort of a good way to think about your models and I think add quite a bit of information. The other one is the fact of a 3D element can be counted in 5D in model-based takeoff, but annotations can't. So an example I always like to use when I'm presenting is mop sinks. For some reason, in a lot of models, mop sinks are always two-dimensional elements. I'm not sure if there's like a bad family out there or no one knows where to find it. But basically, for those of you unfamiliar with Revit, that means it's just a simple two-dimensional drawing sitting on top of a floor plan. So then if we're using a model to do a takeoff, we actually don't see that element. Whereas just a 3D box the same size as the mop sink that has the name mop sink will at least give us the knowledge that it's a mop sink. And finally, be wary of what I call SketchUp syndrome. So I'll give a quick example of that too. But essentially, it's creating in-place masses or in-place extrusions. And the reason that they are dangerous is because they usually, their quantities and areas are usually taken off inaccurately. An example of if you can schedule it, we can schedule it. A great example is a finished floor schedule. And so you can see on the plan we have a finished floor plan, and then on the 2D documents number 2 we have a finished floor schedule. And again, this is a 2D document, so that would be from a PDF. So if that's all that we're given, then we can simply look at it, and we have to dig through it, and we can highlight. We can still get the information, but if we had the ability to schedule it ourselves, or even pull out the schedule, we can bring it into Excel. And let's say we only want to filter by PT1 or VT1 or maybe just all of the toilets or something. It makes life a lot easier. And again, the whole point of making life a lot easier is making sure that we're doing accurate takeoffs from your design document. And so SketchUp syndrome, this is a good example of sort of in-place masses, and this has nothing to do with the architect or the design team. They're actually pretty good, and I like working with them. The model's actually not bad, but there are some examples inside of generic models. So if I isolate what's called generic model category, this is what you see. And then if I isolate the in-place masses, this is what you see. And so the danger here is if you're looking on the inside of the building, there's a whole bunch of thick walls that are, I believe most of these are existing, but let's say we had to pull off the existing, we would actually have no way to accurately pull off the area of these walls using a model because of the fact that they did in-place components. So just avoid SketchUp syndrome. And then finally, we're going to jump into some demos. And what you see here is just a screen cap of on-screen takeoff on the top left, and on the right is a next-tier wall takeoff from a project here in Connecticut. And what I want to show you here is just sort of that relationship between what's happening in 2 dimensions by an estimator before model-based takeoff and what's happening in 3 dimensions on the right-hand side. So the reason Assemble sort of became one of my biggest drivers for 5D and sort of I pushed it pretty hard is that it really easily allows the barrier of entry is pretty low. So it allows someone who doesn't have to learn an entirely new software or complex software. You don't have to use a giant big BIM machine to run it. You don't need a whole bunch of RAM and video cards or anything like that. And but it actually gives you the access to the data that you need to do proper quantity takeoff. So we're going to jump in. So here we have an example project in Assemble. And so what I'm going to try and do here is I'm going to try to go through sort of the way that we do things now and some of the little tips and tricks, and then also show the new Color by Properties tool, which I believe is releasing soon, and sort of the power of the Color by Properties tool for takeoff. So basically, one of the great things about Assemble again is that it's web-based. So I'm sitting in a web-based environment right now. You can see I'm in Google Chrome. On the left-hand side, you can see we have all of our categories. And for those of you who are Revit users, you completely understand what this means because you're familiar with setting categories to families when you build the model. But for someone who's never ever opened Revit in their entire life, to have this list on the left-hand side, it's pretty straightforward to get a feeling for what things are. So if you're taking off millwork, for example, well, Revit doesn't have a category called millwork, if that's the term that you're comfortable using. But if you go through, you can kind of, by the process of deduction or just simply looking at it, you can figure, oh, maybe casework is what I'm looking for. And you can easily highlight the casework and take a look at the casework in your project. And so that immediately is what I thought was pretty neat, is the fact that immediately you can start using data from the Revit model without actually having a core knowledge of the Revit software itself. And so what I wanted to show first was sort of the introductory way of thinking about 5D or model-based takeoff, and what I call brute force method. And so essentially, instead of setting up conditions and rules, which is what I'm going to show you next, and it's, again, to take it one step at a time and get a sense for what's happening here. Let's say we want to do a wall takeoff, or maybe we're in charge of doing some site walls or something like that. And so just at the core of it, if you were doing a site wall takeoff, you're going to go into the site plans, maybe look at elevations, and you're going to dig through all these different two-dimensional drawings, and you're going to try and find these site walls, and you're going to try and find their areas. So by a brute force takeoff, what I mean is that instead of going through and isolating by this wall type and all these crazy conditions, if all you're doing is taking off these walls, if I just hold Control and I click around, I can actually select these 5, 6 walls here. You can see they're selecting them over here, but at the same time, I'm also getting a total area on the top. And so now you're visually understanding what these walls are doing. By looking at this, you can see there's no foundations included. So if you know there's foundations under it, you know that it's missing. So you have that connection. If I just handed you a piece of data that said 92 square feet, you might not know exactly what I was talking about. Is it 3 feet below? Is it missing some information? And so on and so forth. So by brute force, what I'm doing is I'm just manually selecting what I want to take off, and I'm just looking at the square footage. And maybe I'm in Excel or something, and I can type in the value. Then what I can do is I can simply go to my properties, and I can color it, just like an on-screen takeoff. So again, I'm going to go into color overrides. I'm going to set the color, save the color. And now if I hit this little button here, which says toggle color overrides, and if you want to use keyboard shortcuts, you can press T on the keyboard, and you can see it's going to highlight it red. So now I know it's red. I know I've taken it off. I might have put it in my Excel sheet or something. And so basically you're doing the exact same thing you would do an on-screen takeoff. You're just doing it in 3 dimensions. So that's cool, and that's what I call brute force, because you're just manually clicking in and you're digging into the information. So if you wanted to look at this window type, for example, you can select it. If you just hold the mouse over, it's going to tell you it's called existing double hung. If you want to dig through and you want to find what window type it is, it's type mark A on the bottom right here. So you know it's type mark A. So if you wanted to count this, you could just right-click and say, okay, select all 68 by 84 inch windows, and it's counted. It's just selected them all, and it's telling me there's 31 of them. And so I can double-check it. I can hit the little eyeball here, and I can double-check to see what's selected. And if I know if I know there's more in other areas of the building, well, then maybe I'm missing it, or maybe the data is not correct. But at least now I have that connection instead of someone just handing me a piece of paper or an Excel sheet that says 31 windows. That's what I call the brute force method, which works, and it's a great way to sort of get yourself into the model and understanding sort of the data that's involved. But the way that you want to do takeoffs, especially when it comes to if you're going to do an overall, maybe you're doing an entire exterior wall takeoff, is you want to create rules. And the big reason that you want to create rules is that if you were to do a brute force takeoff of exterior walls, so let's say we just selected all of the walls, or maybe we right-click the exterior walls, they select all exterior walls, and then we do that takeoff, and then maybe we save this view for later. And this is, you can see it's 33 selected. What's happening here is by selecting the walls and the instances themselves, we're actually using the element IDs, and you can even see in here it says instant ID. The problem with this is if there's a new version of the model, maybe a year from now or something like that, there's a new version of the model, or maybe a couple months from now, and we load that new version and we want to do the same takeoff. If we pull open the exterior walls and they added walls, then those aren't going to be selected because it's instance-based, it's element-based and not rule-based. Whereas if we do rule-based and they add exterior walls, then those are going to be counted in the new takeoff. So to do a quick exterior wall takeoff, what I typically will do is explain to, again, non-Revit users how to look for information on how to filter things. So a perfect example is for exterior walls. If we look around at the exterior walls, now I'm familiar with this model, so you can take my word for it. But basically the way that this design team works is that they have EXT underscore before all their exterior walls. And for the interior walls, they have INT underscore. So they might be using the correct functions, but I know for a fact, because I'm familiar with this model, that INT is being used for interior and EXT is being used for exterior. So that's a real quick and simple way to say, okay, maybe that's something that we can filter and sort by. So I'm going to go under visibility settings. I'm going to add a rule, and I'm going to say show only category name walls. And again, the reason we're doing this and not just selecting them is now if the model gets updated and they add 3 or 4 new exterior walls, they're going to get pulled into this takeoff when we update the model. And so now if I update this, you'll see what it's going to do is it's going to isolate the walls. So not only does it update it in the three-dimensional view, but you can see it also updates it in our spreadsheet here. It's only showing that one category. Now, okay, we only want to see exterior walls. So again, if we knew the function was correct on here, we could search for function as a property. But for now, I'm going to search for type name. And how do I know it's type name for those that aren't Revit users? If you select the wall, and you pull open the properties, and you dig through, and you look for where it says existing, CEXT, so it's family and type or name. That's how you can tell. This is the actual parameter I want to look for. So I want to look for name. I want to look for type name. So if I look for type name, you can see I'm going to get a whole bunch of stuff because it's not just looking for wall type name. It's just looking for any property for the type name. But if I type EXT underscore, you can see all of the EXT walls are coming up. So if I just wanted to isolate one wall, I could. But if I want to isolate every single wall that has EXT in the beginning, you can see it pops up and says contains EXT. Now I'm looking for all type names that contain those 4 characters in exactly that order. Now if I click update, you're going to see all the exterior walls are going to show and all the interior walls go away. So just like that, we have an exterior wall takeoff. And now if we want to see the different types, you can see they're here. If we want to select them, we can select them. There we go, I'm selecting. You can see in blue I'm selecting them. Now the problem here is with the current method of color override, you notice how all these pink and magenta walls are showing up? That was stuff I did in other views when I was messing around. Those save into each view. So take off and you open the model, you're going to see the wall colors that somebody else did for their exterior wall takeoff, which maybe you might not want. But for now, this is what we have until the new update comes out. So for now, let's say we wanted to do our own takeoff. I want to select all of the 1 foot 1 inch existing exterior walls. I would do the same thing. I can go into color override, and I would change the color of it. And you can see it already has some colors, but that's all right. So if I want to do color override, click save. Now you can see it's overridden, and I can turn it on and off. But now if I wanted to do all the walls, I'd have to actually click each one of them and apply a color override. So you can see how that can be a little bit of a pain, and it's also model-based, so it carries over to other views. With the new color by properties tool, if I pull up color by property, I can turn it on. And what this does is it gives you an entire list of parameters in the project. So if I know that I want to isolate it by type name, I type type name, I click type name, and automatically it's going to color all the walls by type. And then you can actually modify and manage these colors if you want, if you're someone who has a color scheme that you use all the time. But now you can see visually and immediately, you can see, boom, here's all my wall types. I've got all these different wall types. If I want to see all the exterior 1 foot 1, it's this dark red color. If I want to see all the reds or all this magenta color, you can see they're there. And so you can see how much quicker and more powerful that is. And visually, it's also an extremely powerful tool because now immediately you can start seeing how this model is broken down and where the areas are and maybe where the takeoff needs to be focused. And the other great thing about this is that it's view-based. So if you set all this up and you save this view, it's only going to affect this one view. So if someone else does an exterior wall of some other piece, or maybe they're doing perimeter, I don't know, a perimeter takeoff or just something else, they won't get your color scheme. They can open a fresh view and it's not applied to the element. So the same thing applies to interior walls. So let's close this and let's quickly take off some interior walls. I know again that this model, they use INT. So if I type INT underscore, again, if they had correct functions, we could just use function equals interior. But right there, I'm going to look for everything that contains INT and click update. Now you see it's going to flip. If I turn on X-ray, you can see in context. Those are all the interior walls. So you can see they did a pretty good job at least naming their walls, which is nice. And we can get a sense for all the interior walls. And now the color by properties, again, you can do the same thing. If you want to do by type name, or actually for interior walls, maybe we want to do a type mark. So if you look on the 2D drawing, and you know, for instance, that this wall type in here, the easiest way for those who aren't using Revit to find Revit parameters is if you know, if this is a known wall type, so maybe you know that this wall is an A1 because you're familiar with the plan or you have the 2D plan in front of you. What you do is you click the wall in the model, so click the known element, go to the properties, and look for that value that you know. So if I know this is A1, I'm going to dig through and look until I find A1. You can see it's not in an instance, so I'm going to look under type. If I scroll down, you can see right there, A1. So that's how the design team is actually creating their drawings. They have this piece of information and they're tagging it. So now that you know this information, and this is a great tip for lighting takeoffs as well. If you know there's a PQ light, you go to that room, you select the light, and then you look down, then you can know exactly what parameter, or in this case they're calling it properties, what property is being used to assign that a PU1. So then if you go and you want to set colors like that, let's go to our color by property tool, and I'm going to go to type mark, and click type mark, and you can see right away you've got all of your wall types in the project, A1, A2, A3, B1, and so on and so forth, and you also have them colored by type. So it's automatically setting up conditions and rules, which if you're an on-screen takeoff user, I believe you do manually sometimes, or you have some that you pull from other projects. And it's automatically setting them up for you. And all you can do is you can go and I think you can set up templates and whatnot of colors if you really like, but you can see it's automatically setting your colors for you. And let's say you just want to isolate and look at certain ones here. You've got your takeoff here. So you can select those walls. You can isolate them and look at them. So maybe I want to look at this one. I can isolate it. You can see I'm looking at the walls in there, get a sense for what, again, connecting the data to the models. You've got your takeoff, so if you want to know all the A1 types, so it looks like all these are A1s with different installation or something, you can select all the A1s. You can see it's giving you 14,160 square feet. If you click the eyeball, you can actually zoom around and get a sense for it, and maybe there's some stuff that's wrong. This is where it's key again. Instead of just trusting the data, you can go in and say, hey, wait a minute. This is not an A1 wall type. It's on a skylight or something like that. You know it's correct. It's actually modeled wrong. And then, of course, you can also take this information now. Now that you have this isolated view, you can export this to Excel. So I can export to Microsoft Excel, and it'll pump out an Excel sheet for me. Now you do have that data you use downstream as well. So that's a quick overview of the Color by Properties tool. You can see how powerful it can be. And again, it's view-based and so on. I guess the other quick thing I wanted to show you, because I wanted to touch a little bit on MEP, is maybe just give a quick tip on MEPs, that MEP takeoff, that I think will help most people who are not familiar with Revit on how to isolate and do takeoff. It also shows the Color by Properties tool, some good things there too. So let me leave without saving. I'll quickly do a plumbing takeoff. So this applies to piping, and it also applies to ductwork. So one of the things with Revit when it comes to plumbing, pipework and duct, is if I select these pipes, you can see there's a plumbing drawing here. If I select these pipes and I see what type it is, you can see it's called just PVC DWV. So if I select all those pipes are called PVC DWV. The problem is they're all different sizes, and they're all different sizes here. So if you just wanted to take off this pipe, well, you can take off the pipe, but obviously the size is pretty important when it comes to estimating. So what you do is simply add a parameter called size. So if I go into columns, and again, this is the old way, and I'll show you the new way. If I add a column called size, and I'm going to move this up so we can see it in view. Maybe we'll get rid of a couple of things. So you can see now there's a column here called size, and it's giving us, for the elbows, it's giving us 3-inch diameter, 3-inch diameter. For the fittings, it's doing the same thing. And then for the actual pipes, if I pull this down, you can see it's giving us 2, 4, 6, etc. So let's say we just, again, this is the old way. This is before Color by Properties. If we wanted to just select all the 4-inch pipe and color it a certain way, or take a look at it, what we can do is we can actually change our sorting and grouping. So if I change our sorting to size, or I create a new group, so you can see how to create a new one, I say by size, I can say category name, and then I can say size, and now you can see it's going to first. So now if I pull down pipes, you can see those are all my pipes. I have 3-inch, and I want to see all the 3-inch diameter pipes. Select the 3-inch diameter pipes. I can see them in my view here, and then I can also color them. Maybe I go through and give them a color. But I can also take them off, right? So I can look at them and say, okay, I have however many 193 linear feet of pipe. If I hit T, I can see the color override. That's how you would do it now. Same thing with ductwork. You set up size, you can sort by it, but then you have to manually click each one of these sizes to dig through and get a sense for it. But again, using the new color by properties tool, if I just color by size, and this can be done, you can see this is an entire plumbing model, I'm not even isolating. You can see immediately it's coloring everything by their sizes. And this is, for those of you familiar with Navisworks, this is how Navisworks color overrides used a lot, maybe some of the coordination models you've seen. So you can see each pipe fitting, and each pipe has its own color. So if you go through here, the 3-inch diameter pipe is your green. So automatically it's going through and it's giving you a sense for all the different size. Maybe it's giving you a sense for magnitude. If I zoom in a little, magnitude of how much of each pipe there might be. So if you're doing a takeoff, you can look at it. And again, the overall goal is to attach the data coming out to the model. And so I think these are some good examples of how you can do that. So what do you think, Don? Anything else?
I think that was great. Thank you very much for being here today, Jeff, and thanks to all the people who have who've joined us via the internet, and we look forward to seeing you again soon.